welcome back to the channel. So the next problem on the list is LeetCode 300 longest increasing subsequence. Given an integer enums, return the length of the longest strictly increasing subsequence. A subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. Okay. So the longest increasing subsequence is 2 5. No, this is not 3 7 101. Okay, 2 3 7 and 101, or 2 5 7 and 101. So like this can be easier, I guess. The thing here is, for each element we have to decide whether or not to keep it or not keep it. So let's go. Let's create, like, let's do memoization. uh, let's keep it as dp and index I. If I equals to the length of nums, we have to return 0, and if we keep it, keep it, or let's say use it, use, no use. So if we are using it, then we have to use +1. No, actually we don't use it. If we see it as an increasing sequence, then only we'll use it, or else we won't use it. If nums of I is less than nums of, and it is said strictly increasing subsequence, nums of I +1, if the previous element is less than the next element, then and another thing is, if I +1 is less than length of nums, then we have two options, either to use it or not to use it, or else we can, like, we don't need to use it. And let's keep use equals to 0, 1 plus. Now we have to return the maximum of use and no use We call dp of a 0. Let's try this. And 0, we are getting one less value. And we don't know why is that. Let's think about it. Why is that happening? Maybe it is because we are not using the last value. The values will be between 1 and 250. Let's see. Well, this is working fine. Can you come with an algorithm that runs in order of analog and time complexity? Well, this would do in order of n time, right? Actually, it is order of 2n. But if we use so let's submit this and see how this will work. And we don't know why is this. Let me take a short break. I have to attend for something. So, well, we're back. So let's see what's going wrong here. So 0. So first 5, I mean backtracking. So from the end of the stack, 5 0 0, 1 2 3 4 5 6. Okay, 0 4 1 0. Okay, then 2 and 1, 0 and 2, 0 and 2. I got it. So we are not using the I plus 1th variable, that is lost variable. But we are using 4 4 8 9. 4 is less than 10. Okay, well, that is wrong. We don't have to check the adjacent values actually. Well, we are somewhat close. We have to think a different way. So 4 is obviously less than 10. 3 8 9. Well, let's not waste much time. Let's ask ChatGPT. Is lead code 300? I see the intuition is is to decide whether or not to use the current value. So let's do one thing instead. I got the thing here. So instead of Let's pass two values instead. So dp will take I comma previous value. Initially the previous value will be none. If the current value is less than, current value is greater than the previous value, will pass the nums of I, or else we'll use the previous value itself. Now if previous value and but there is a problem. We don't need this plus one now. Well, looks like it is working fine. Oh, we didn't actually took the ChatGPT help. Let's submit this. Oh, it is taking way too much of time. Now let's see. Based on the previous value. Wait a minute, is it memory limit exceeded or time limit exceeded? Oh, well, that's what I thought. We exceeded the memory limit. Can it be optimized? So is branching into the problem. Let's walk through your current approach, confirm it's correct, and then reason step by step about how to optimize it conceptually. Okay. So well, we are. I mean, I can think of a way to make an iterative solution, not iterative, recursive solution. But the iterative approach is proving to be much simpler, which is called tabulation. We are currently doing memorization. Initially, when I start, I couldn't understand the recursive problems fully, but I am now Getting only recursive solutions for DP problems means the length of the starting from index is given that the previous chosen number was okay. Your second argument previous is a number, not an index, and that's what limits your caching power. Okay, the same numerical value may appear multiple times at different positions, and each has a different valid country. Can refer to index 0. So your allocations are being order of n instead of order of n square or less, and in Python that becomes slower, and so cache ends up being order of n into value range. Okay, the classical optimized DP version indexes both positions, not values. Current index being contained j index of the previous element. Oh, that's great too. Let's try that one too. Comma j. If j equals to none, let's not keep it like this, equals to none, I j the time complexity decreased a very little bit, but I don't know about the space complexity. So take or skip. We are doing the same. Take or skip. More efficient caching time, order of n square time, and order of n square space. Patient sorting by research. Okay, if you want order of n log n time, there's a different perspective altogether. Okay, to maintain a list of tails where tops of k equal to tails of k equal to small tail value of n. Okay, so tails function nums bisect top bisect left. If I in of equals to the length of tails to index. I got it. So what we are doing here is we are taking values from numbers and we are appending the value to the numbers. If we see any number, like if the current number which we draw from the numbers returns the length of the list tails, that means it is the biggest number in the tails, so we are appending into it. Since it is the biggest, we can add it to the list, which will make it an increasing order of elements. If it is not, then we are updating the ice position. We will get the total elements. So let me do that too. Before that, let's submit this. The memory limit is still a problem, so let's ditch this part. For I in nums, index equals to, or let's say for value in nums, index equals to, and let's give tails equals to an empty list. So we created an empty list now, and bisect left of the value in tails. I think first the list and then the value. If index c is equals to the length of tails, append nums of value, or else of index equals to the value of it is working fine. And since we are going through each element in the numbers, this is the order of n time. And if the worst case scenario, this will be order of each search is a log n time, and in the worst case it will become order of log n log n time. And we can have the list of all values to see, just like this: 0, 1, 2 and 3, and here in this case 2, 3, 7 and 18. So what we are doing here is we'll insert the 10 first, and then we'll check what will be the ninth position if we have to insert it into this list. 9 will give the 0, which is not the length of the list, so we'll update with 9 the first position. Let me directly print the value as it goes, then you can easily understand instead of explaining. Let's print the tails. So the tail initially will have one value 10, and then one value 9, one value 2, and later we'll have 5 and 2 comma 5. We'll have 2 comma 5, and in the next iteration we'll have 2 comma 3, and in the next iteration we'll have 2, 3 and 7, and in the latter iteration we'll have 2, 3, 7 and 101, and in the next iteration it will be 2, 3, 7 and 18. See, just like this, 10 we'll binary search into this list. We'll find the, 9 will, like 9 is not the biggest element in the list, so we'll get 0 as the value for index. 0 as the index, so we'll update the value. And later 2 is less than 9, so we'll get 0 again. And for 5 we'll get 1, so we'll append the value. And 3, and so on and so forth. So let me submit this. That's it, guys. Well, this worked out very well. Let's see how others did the. So this is the order of n square max equal to 1 into 5 if nums of j is nums of I. If max length is less than 40. This is the order of n square, which is uh, this is very simple thing. What happening here is we are going, like, we'll select this value and we'll check all the values that are less than 10 in the increasing order, and we'll append the maximum value until that point, and we will go on further like that for each value. Finally we'll return the maximum value in the DP. Let's see the topics too. Okay, well, that is a good problem. We have learned something new. I hope you guys understood the intuition. If you like the video, put it and share it with your friends, and don't forget to subscribe to the channel. We'll meet you again with another video. Until then, keep learning and keep pushing hard, and goodbye, guys. Also, leave a comment so that we'll get a better reach and I can address your doubts as well. Thank you, guys. Goodbye.